Okay, and hopefully we are on. Not seeing anything appearing. Oh! Almost ready. Okay, and we are live. So welcome to a new CoolDudeClem's Electronic Workshop live stream. Now, before I start, I better just go to what I'm gonna do in this live stream. Now, fellow YouTuber Stefan0719, I think I've said that right, pointed me to a video where a friend of his had designed a radio transmitter circuit. You know, a low power radio transmitter circuit, and asked me if I could build up that circuit and do a few tests on it. So that's what I'm going to do in this video. So this is the circuit. Let me just bring up my thing here so I can actually see what the camera is seeing. Hopefully you can see the circuit there. Now, I did not design this circuit. This was designed by his friend, so let's build that up and see what we get. Also, I'm going to bring up the live chat on my tablet here, if I can just figure out how to do that. Hopefully I'm transmitting. I think I am. And by transmitting, I mean doing a live stream. No, I did not say go into Google, you stupid piece of... I'm no good with these kind of things. I'll be with you in a minute. I'm just trying to bring up any live chat on here. YouTube, I think that's the one we need. Okay, 5 hours later. Now let's see if I can get to my channel. Now if we can just get to the live stream. Oh, there we go. So I should bring up some live chat. There we go. So I can view the live chat messages. I'm doing this. Right. So, hello to all 5 of you watching right now. Right, so let's get started with this circuit. So, I'm going to build this up quickly. I'm not going to keep the circuit, I'm going to sort of tear it down when I'm done, but let's see, we need an NPN transistor, so the original circuit says I should use a BC547 or 548 or one of those, but first transistor I've come to is a 2N3904, which is basically the same thing, so I'm just going to put him in there. I mean, they're pretty much interchangeable. And I need a whole bunch of 1 nanofarad capacitors. Fortunately, I prepared, so I've got all the components ready. Oh, and in answer to your question, Arlen, about the cassette player, that is going to be used as the music source. So when I start transmitting with this radio, we should be able to hear what, you know, the tape in here coming through a radio. And the radio I'm going to use is this old 1980s receiver that I've got. Got one of my Eddie Roll speakers hooked up to it. Let's just make sure that's working. It was last time. Yep, seems to be working. I'll just make sure that AM is working. Oh yeah, that's working. Don't know what's got that weird reverb there. Some of the AM stations do that, but yeah. Talking about football, so that's pretty much AM. Hopefully this should be able to transmit about a foot or two. I'm not exactly sure how, you know, what kind of range we're going to get, but adding some capacitors. Right, so let me just bring in my schematic here. And too much waffle, not enough building. So I need a couple of 1 nanofarad capacitors between collector and emitter. Stick those in there. There we go. Right, I need a couple of 1 nanofarad capacitors between the emitter and base, so I'll put them on this side of the transistor. Get in there, you little bugger. Okay, I need another 1 microfarad and 1 nanofarad capacitor to connect the coil to the base, so I'm just going to put that one in there like that. Going to be testing quite a few different coils and see what we get out of that. Don't know if you can hear the cat in the background. Don't know what he wants. So I need a 3.3K resistor between base and collector. It's getting very, very crowded on this board. Oh, and someone's asking me, Alan's asking me what I'm going to do with my old scope. Well, at the moment I've got that under the bed. I'm going to use that as my backup scope just in case anything, you know, in case anything bad happens to this one, which I really hope does never happen, but just in case something bad happens to this scope, and I hope that never ever happens, but, you know, just in case. So, let's see what else we've got. I need a 2.2K resistor between collector, at the collector, so let's put that in. This is a 2.2K, I think, so I'll just have to stick that one in there. I've probably made about 15 billion thousand connection errors, but we'll see. And a 47K. Oh, is this a 47K or a 4.7? Yeah, it's a 47K. Thought I'd accidentally grabbed a 4.7K there. That wouldn't have been good. Right, so the circuit's almost built. So let's stick a coil in here and see what it does. So the coil goes between collector and base. Well, not collector and base, but between the... Hold on a minute. I don't think I've put this resistor in right. I told you I was going to make a mistake. Just have to move those up a bit. Come on. Get in there. Right, should be ready now. Should be built now. Okay, Joseph Hutchinen is asking, what am I building here? I'm building a little radio transmitter circuit. And also, I'm going to put in a link to the original video in the description, so if you want to watch that one, you can. It is in German, but if you speak the universal language of electronics, it shouldn't be too difficult to understand. I'll just put my coil in, and we'll see if this circuit oscillates, and if it doesn't oscillate, well, we'll just keep tinkering around with it until it does. Right. picture's way overexposed on the camera. Oh, I know what I've forgotten. Power connection wires. It's not going to work if I don't put any power into it. So, then goes our positive to the other end of the 47k resistor. Now our negative. If I can just get the insulation off the end of this wire. Yes, this is a medium wave transmitter, but it's going to be able to do other frequencies as well. It might even be able to do shortwave on this, although that other radio doesn't have shortwave on it, so won't be able to properly test that. But okay, somebody keeps saying video hatch here. I don't know what that means. Right, so let's power this up and see if it oscillates. So, I'm going to turn my scope on. Where's the power button? Grab a test lead. Find the little clip that goes on the end of it so I can clip this on. So I'm just going to test that the circuit oscillates for now, and then if it works, we'll hook up an audio source and see what it does. Okay, it's hooked up to the scope now, so gonna turn power on. Well, I saw the line shift a little bit, but I'm not seeing any sign of oscillation here. Try adjusting the voltage. Still not getting anything. It might be oscillating, but it's just too... It's not very strong oscillation. Okay, that's as... How's it going? There's absolutely no sign of oscillation here whatsoever. So what have I done wrong? I knew something like this would happen. Oh, actually, have I... No, I really don't know what's going on here. Although I don't think I've got this connected up properly. Oh yeah, I see what I've done. I see what I've done. I've put this coil in the wrong hole. Should be in this hole instead. Oh, we're getting something now. Let me just turn the scope down. We've got it. The circuit is oscillating. Sure what frequency that is. I'm sure it's not 50 Hertz. Of course, I haven't connected up my ground wire. Well, I thought it was too good to be true. I was just picking up 50 Hertz crap and I thought the circuit was oscillating. Let's see. Just going over my connections here, trying to figure out what it is I've done wrong. See, the coil's got to go to the collector of the transistor, that's in there. And the other side of the coil, oh, done it again! Not pointing the camera at the thing. So let's see, we've got the coil of the transmitter going into the... we've got one side of that coil going into the collector. Let's make sure this thing is getting power. I've got this little meter right here, connected in line with my power supply. I've got this USB power. Now I can just plug this into my scope because that's providing that can provide 5 volts USB power. So let's plug that in. Okay, we are getting 12.1 volts into the circuit, so that is working. I'm actually going to back that down to 9 volts because that's the recommended supply voltage. So the circuit is getting power, but it's not providing any oscillation. What is wrong with you? Why are you not working? Why you not work? Oh, could it be that I've just missed a capacitor? Yep, I think I've missed out a capacitor. There should be a 100 nanofarad capacitor between the where these two resistors meet and the ground, and there isn't one, so that could be the reason. Let's see if I can put that in without shorting anything. I'm trying to get this resistor so that's out of the way. I can put those both in the same hole. Yeah, we could try turning it on and off again, but that's pretty much what I've already done. Right. Let's see if it's working now. Still nothing. After all that, still not getting any signs of life here. Oh, and I've left one of my meters on. I didn't know that. Right then. I think the best thing to do, just take this whole circuit apart, rebuild it, and hope for the best. Because I'm sure I've missed some connection here, so let's do that. Right, now I've got most of those components off. I can see what we've got here, so we've got the coil that's going to the collector. The other side of the coil is going through this capacitor and into the base, like it is in the schematic here. Just checking my schematic. Yep. Right. Put a 33k resistor in. If this doesn't work, I will try a BC547. Maybe it just doesn't going to work with a 2N3904. There's a 103 capacitor. I'll put him in there. 2.2k. And make sure that is going to the collector. and our 4.7K. Come on, get in there. Right, well, let's see if it's working now. Hope I haven't got a duff transistor here. Could always be the case. It's still not doing anything. Yep, I'm right at the maximum amount of amplification. There's absolutely no sign of life. Well, I really don't know what's wrong here, so I'm gonna try a BC547 instead. I'm sure I've got a few lying around. Just hold with me. I'll be back in a second. Got a little box here of bits and bobs. That's a BC557, that's PNP, that's not what we want NPN. And this one's a BC546. Gotta remember the pins are reversed on a BC546 opposed to the 2N3904. No, I see something. I saw some activity on the scope while I was doing that, but that might just be... Nope. No such luck. While I was putting that transistor in, the wave was going all up and down like crazy, but that was just DC. Alright. I'm gonna go over with my multimeter and make sure everything is connecting. And that was a bit scary. Didn't know the leads were gonna flap about like that. Almost hit my scope. And now I've pulled one of the resistors out. That's what it was picking up before, and I thought it was oscillating. Come on, get in there. Stupid resistor. Right, turn the power off and make sure there's nothing going in. I'm going to put my multimeter onto continuity and I'm going to check every single one of these connections and make sure they are making contact with the transistor, because this circuit should work and I don't understand why it isn't. Okay, we've got continuity there, there, and there. Alright, let's try the base, make sure this has got continuity. I can just get that in there, yep. So maybe it's this resistor, maybe that isn't connecting. Do you ever have one of those days when no matter what you do, you just cannot figure out what's wrong? I'm having one of those right now. And I just do not understand why this isn't working when everything is how it should be. We haven't got any bad connections or anything like that. Everything is connected where it should be. So nothing is shorted, nothing is open. I really just don't understand this. Couldn't be a bad transistor because I tried 2 transistors and it's unlikely that both of them are going to be bad. So, what have I got plugged into the USB port of my scope? Well, that's that little meter here, because that needs its own power supply. And although I don't know what the USB on the scope is for, I do know that there is 5 volts USB power coming out of that, so that can power up this little meter here, and I can measure the voltage and current that's going into my circuit. Right, let's try one more time. I want to make sure that my coil isn't open, because that's always a possibility that my coil isn't conducting. If my coil is open, that could... I think I found... No. Thought I'd found the problem then. I thought this coil was open, but no, it's conducting. Alright, I'm going to hook the scope back up, but I'm going to connect up a different coil and see if that works. Actually, I'm going to connect this to the transistor's base instead. I mean the transistor's collector instead, and see if we get anything between the collector and the emitter. Hopefully without shorting anything out. No, don't pull that transistor out. Right. Let's power on and see what happens. And again, no sign of oscillation. Alright, I'm going to pull out a different coil here, because maybe that one isn't working. I'll try a different coil. And again, nothing. Well, sorry, Stefano719. I tried. I really tried. But this doesn't seem to want to work. Try a ferrite bar and try to increase the inductance, maybe that will fix it. Doesn't look like me or anybody else knows what's going on with this circuit. See, I've got the transistor connected the right way around, haven't I? That's collector, there's base, and there's emitter. So that is connected the right way around. Alright. I'm going to try connecting the power without this 4.7k resistor in the circuit. Maybe it just needs a bit more power. Now where can, you know, because these leads are pulling out components as I'm trying to get things done, I'm just gonna make a test point. So I don't risk pulling components out with my test leads. Alright, yeah, I'm going to test that transistor in a minute. See if that's the case. I don't know why I just said cois. I do that. Sometimes I try to mix two words together and I end up saying something completely different. Right, so I'm going to put my scope leads across this transistor, and the collector and the base. I mean the collector and the emitter. I'm going to move my power down to here. And oh, we have some activity. Something is happening. Maybe it just wasn't getting enough power, I don't know. It is oscillating. It's not the best waveform, but we've got something. It's currently going at about 447 kilohertz. Let's see if we can get that up to around a megahertz. So I'm going to pull the magnetic core out a little bit so we can tune this. Frequency should go up. Yep. Okay. We're at 988 kilohertz. Well, that's close enough. So, what can the only trouble is I don't know what I'm going to do about the resistor. Because like this, I won't be able to do audio modulation. Alright, I'm going to move that to the other thing, see if that oscillates like that. Yep, I think that is the problem, because like this we don't get any oscillation. But if I move this to the other thing, so I'm just completely bypassing this resistor here, it is working. It's not the best waveform, but let's see what happens if I adjust the supply voltage. Might clear up a little. Let's get more sine wave like now. I've reduced the voltage to 2.3 volts. And that's looking a lot better. So what I'm going to do is, instead of a 47k resistor here, I'm going to put a 4.7k. And see if it works with that. I'm sure I've got one in this little box of parts here. Got another resistor over here. What is this one? Oh, that's my 15k resistor. That's going to be for the audio input. Let's see, have I got a 4.7k resistor anywhere? I've got to have one somewhere. I'm just looking for a 4.7k resistor. I'll be back with you in a moment. We got one in here. We got any 4.7k resistors in here? No, of course. Just because I'm live, everything that I need is decided to not show itself. I think I've got some in here. I'm sure you saw this box in my previous live stream. Oh, I was hoping I wouldn't have to get this out and search through thousands of little resistors until I find the one I need. There's got to be a 4.7K in here somewhere. I know I saw a 4.7K in here somewhere because I saw it the other day. I distinctly remember seeing a few 4.7K resistors in here. No, that's not a 4.7K. Ah, wait. I've got 470. No, wait. Hold on. Oh, wait a minute. This resistor here is yellow, purple, black, orange. So that would be 470K. So no wonder it wasn't working. So this is a 47K because we've got yellow, yellow, purple, black, red. So that's 3 zeros. 47 with 3 zeros. So let's see what happens when we put this one in the circuit instead. So no sign of any oscillation. So I'm just bringing the voltage up. I'm going to bring it up to 9 volts. And oh yes! Yes, look! It is working! And we've got a much better waveform, so that's working at about 1.02 megahertz. So now, what I'm going to do is I'm going to hook this thing up and see if we can transmit audio over the air. I just need to find, yeah, this could be a bit of a problem. This part of the board is absolutely packed with components now, and I don't know if I'm going to be able to, how I'm going to be able to do this. If I connect the negative, connect the ground, the audio ground there. Now I need to connect the audio input capacitor between these two resistors, so that's where I'm going to put that. And then the 15K resistor goes in series with that. Well, actually this is a 12K resistor because I don't have any 15K resistors, but it's close enough. I feel so stupid now. Getting those resistors wrong. Just making sure that's in there. Right. I'm going to play that. I'm going to tune the radio into about the same frequency. Let's see what we get. So we need to be in AM. Let's get up to about 1 megahertz. So I'm on 1008. I'm not hearing anything that sounds like it could be coming from this though. Let's try to tune this a little. Oh, well, I can just about hear one of the songs I made coming through. It's not coming through very strongly, but it is coming through. If I could turn this coil and aim the coil at the radio. Now I cannot find my station. Well, it's sort of working. Alright, let's just... That's definitely coming from there. Maybe if we just turn... And now I can hear myself. Right, well then, let's see if we can get that reception better. Okay, let's just turn off that noise. And my tablet's getting a little bit low, so I better put that on the AC power. Except I don't have a spare adapter at the moment. I don't have a spare adapter handy. I'll just have to have a look at the chat on the thing here. But with you in a moment. I'm just trying to set this up so I can see the chat in one side of the window. What's the matter, Tails? You look so sad. So we got that in that window. Trying to get my open broadcaster on the other window so I can see what I'm doing. Oh. I want to see the chat. Where is the chat? Right. I think one problem is that this is transmitting on a frequency that's like right on top of another radio station. But I'm going to see if I can tune that in any better, because the trouble is with this one is that it's, you know, it tunes in steps, so it's going to be pretty difficult to get the tuning just right. So, I'll get out this piece of junk. I'm practically sitting it right on top of the radio receiver. I mean, on top of the transmitter. Which I have detuned by knocking it about, but there's not much I can do about that. Got to plug it in, and let's see if we can pick up that radio station on this piece of junk boombox. Just gonna have to adjust my coil here because the frequency, not the coil, and the frequency's gone down, so I'm just gonna put that back up. Yeah, we're about 966 kilohertz. Put this onto radio. Need to be medium wave. This switch is a little bit right. Somewhere along here we should have radio silence. Okay, there we are. We're about on the same frequency that this is transmitting on. So I'm going to say, I beg your pardon? gonna start this playing, and let's see if that comes through onto here. Oh, that's definitely doing something. I think I've got this volume on this way too loud. Now, why are we getting all that hum? I wasn't doing that a minute ago. Is this it? Oh. No, that's not it. There it is. Found it. Just trying to tune this in. Oh, I won't play too much of that just in case, because you know what YouTube is like. With the copyright laws, someone's going to come across that video and mute it. If I play too much of that. So, I think what I'm going to do is I'm going to get this radio, turn it round, and hopefully it'll be close enough to pick up from this thing. But first I'm going to try with this coil and see what this one gives us. So, in you go. Oh, we've got a nice clean waveform from that coil. So let's just put that to one side. This is running at about 787 kilohertz. Looks like BBC 600 has just tuned in, asking how long I've been streaming for. Well, I've been streaming for about 3/4 of an hour. So, I'm going to turn this radio on and I'm going to attempt to tune in on this thing. That's what I really don't like about these PLL synthesized tuners. They just... you can never fine tune them, you know? But I've got an idea. I'm just trying to get this plugged in so I can... Right, so let's try to get 700 and whatever it was kilohertz. Come on, go into AM, you stupid thing. Try and get to 786 kilohertz. Well, the radio's pretty silent around here. I'm just going to unplug the thing and make sure that this is picking up from that. Yep, certainly seems to be. Again, we seem to be on top of another radio station. Alright, let's see if this picks up from the thing. Well, I can definitely hear something, but it's very, very faint. I mean, it's so faint, it's not even registering on the signal strength meter here. Well, I can hear it a little better now. Okay, one of my meters just beeps at me for some reason, I don't know why. Alright, so what I'm going to do is I'm going to put a variable capacitor either across this coil or in parallel with the other capacitor there. Hopefully we can tune this thing. Now, where did I put my variable capacitors at? Just looking for my variable capacitors. Okay, I got one. Right, so I'm going to put this in parallel with this capacitor. Okay. Now where's my circuit? Right. So I've put the variable capacitor in parallel with this 1 nanofarad capacitor here. And this way I can fine-tune it. Can't really see the scope from here, so I'll move the speaker over, but if you notice, when I adjust the variable capacitor, I can fine-tune the frequency. So let's see how well that works. And I'm going to put the other side of the tape on, because if I hear that song one more time, okay, I'm not hearing anything. I know it is modulating because I can see the wave going up and down. It's not just... Well, there it is. Let's see if we can tune that in any better. Try to work out where all that hum is coming from, though. Might be... Okay, I thought it might be this picking that up from the transformer, but that's not the case. Just going to briefly turn my power supply off. There, the hum's gone. The trouble is, that's going to start fading out now because my power supply is not going to power that forever. It's just running on the energy from the... Jeez. Okay, that was weird. Yep, but we found out the source of the hum. That actually started sounding pretty good. So I'm not quite sure what I'm going to do about the power supply. Maybe I can move this around. Actually, what I'm going to do is I'm going to adjust the voltage, the supply voltage, because at a lower supply voltage it got louder. And I left my gun behind. tuning this. I have no idea what this song is. But I think I'm gonna call this a success. Apart from all that hum we've got from the Transformer's power supply, there's not really much I can do about that. But it seems to be working pretty good. Now this says it's on 774 kilohertz, and my scope says that my transmitter is on 773.7. So I'm just going to try to make that so the frequencies exactly match. Now I've gone up, haven't I? Try to get that on 774. Sounds like a mad scientist lab in here now. Right, so that's pretty much on exactly the frequency, maybe just a touch out. Okay, that's about as close as I can get it. So let's see how that sounds when I press play. Well, that doesn't sound as good as when I had that off-tuned a little bit. I'm missing you. All those lovely things you do. I tell you the truth, hurts the way I'm missing you. Well, don't really know what else I can do regarding this thing. So anyway, about 4.77 volts seems to give the best sound quality. If you can call that sound quality, of course. So, anyway, Reddick asks, give us an update on the voice actors. So yes, I am getting on with that, the Star Kids. I've got voice actors for all of the characters except for Red, but I might do his voice myself. As a matter of fact, I've been doing quite a bit of drawing, as you can see. This is just some of the drawings. These are some of the little bits and pieces that are going to be animated. I know you can probably not able to tell head or tail of this thing, but trust me, it'll make sense when I've got it all animated and everything. So, last experiment I'm going to do with this is I'm going to try it with this 25 turn coil and see what frequencies that gives us. So just to wrap up this live stream, let's see what this gives us, and let's see if we can transmit anything with any decent amount of sound quality. So take this coil out and put this one in with the ferrite bar in it. If I can remember where it goes. Come on, get in there. This wire does not want to go in. Alright, there we go. Now just plug in the other side of my coil. Alright, so this is giving us about 879 kilohertz. I'm going to make this, put the variable capacitor to its middle position. So that's 870 kilohertz with a 25 turn coil. So I'm going to tune this to 870 kilohertz. 864 or 873 is about the closest I can get to it. Okay, Reddick, I will have a look at your submissions for the red character. I mean, for red later on. Let's just see what this is picking up. So I'll turn. Well, it's pretty silent. Let's just unplug and see if it goes noisy. Oh yeah. That's definitely working. And I've just knocked a whole box of components onto the floor. Right, let's play this and see what it does.
Night still is sunrise.
Oh wow.
Rain pounding on my window, draws my sleepless eyes.
Oh, that's working.
Witness one more dawn break.
That's working great.
Outside. Oh, I broke down and cried, 'cause I miss.
Again, I won't play too much of that just in case this is, just in case, you know, YouTube's copyright laws decide to mute the video or anything. Anyway, I think that's just about it for this video. I really wish I could do something about this power supply giving up so much hum, because that's what this hum is coming from. This power supply is putting some hum into the circuit. I don't exactly know if it's... Yeah, as I move that around, the hum changes. Do you know what I think I'm going to have to do in the next live stream? See if I can make a switch mode power supply. So, my mind has kind of gone out. It's kind of gone blank now. Let's just turn that off, because that's probably starting to bother me now. So yeah, that is this circuit and how well it works, when I finally got it working, of course. And I think the next video the next live stream I'm going to do is going to be either a switch mode power supply or an amplifier, if I can make one of those work. And yes, I am aware that switch mode power supplies interfere with radio. I'm not, you know... The thing is, as my next project was not going to be, you know, radio oriented, you know, it wasn't really gonna... Okay, show the modified schematic. Well, this pretty much is the same. I haven't done any modifications to this at all, apart from try different coils. Before I go, I will try that with that 2N3904 again, see if that see if it works with that. So I'm going to plug out the BC547. or 546 or whatever it is. Put in the 2N3904. So that transistor was perfectly okay. Anyway, that's just, I'm just gonna finish up with asking a few questions here. Let's have a look. Okay, so BBC 600 says, is some of the hum tape noise? Well, not really. I mean, I think some of that hum was probably being picked up by this from the transformer in my power supply, but yeah, the rest of that hum is just, you know, this power supply interfering with this circuit. I mean, everything's all out in the open here. It's bound to pick up some stray noise. Oh, he also asks, how do I design circuits? Well, just experience, really. Just experience with, you know, experience. I guess that's the only way I can explain it. Anyway, yeah. He also asks, can I explain the schematic? So, yeah, I'm going to try and explain this as best as I can. So, an AM radio transmits a frequency. You know, at the moment this one is running at, according to my scope, 873 kilohertz, which is the carrier wave. So, this transistor gets feedback from this coil here, and this coil and this capacitor, they form a tuned circuit. So that causes this transistor to oscillate at whatever frequency this circuit resonates at, if the camera will focus on it. So that produces our sine wave that you can see there, which is our carrier wave. And then when I put an audio signal in, that just varies the amount of power going to the circuit, because as this is going to go up and down, you know, in time with the audio signal, you know, in time with the sound wave. I'm trying to explain this. Now, as the amplitude of the audio signal goes up and down, that's going to modify the amount of power that goes into the circuit, which is going to affect the amount of, you know, the magnetic field coming off the inductor here. And then, of course, that can be picked up and decoded by the radio tuner. I know I completely botched up that explanation, but, you know, I'm just trying to make this up on the fly. Anyway, well, that's just about it for this video. So, yeah, I'll see you in another live stream or another video, depending on what I, you know, can do. Because I'm going to get back to working on episode 3 of the Star Kids. Since I've got most of the line, you know, voice actor lines now. Oh, Gabriel, yes, I listened to your audition for the next 2 the next, you know, the 2 redos you did, and I can work with those, so that is perfectly good. So, I'm gonna stop now, so until next time, goodbye.